Today we're going to talk about air masses and weather fronts. So first I want to talk about air masses. There is a nice map of the world right here. So there's a lot of different types of air masses, and air masses are named using two letters. And they're going to look kind of weird because the first letter is lowercase and the second letter is a capital. So the first letter refers to where the air mass formed. If it formed over the ocean, it's called a maritime air mass. Thus, the name of the air mass starts with an M. If it formed over land, it's called a continental air mass. Thus, the C. Now, the second letter refers to the source region. That means what area of the Earth that it formed over. For example, if I have an air mass that formed clear up here at the top of the Earth, it's going to be full of cold air. And if it's full of cold air and it formed near the top of the Earth, then it's going to be called a CP air mass. That stands for continental polar, or a CA air mass. That stands for continental Arctic. So, there's a spot on your worksheet where you can pause the video and just write some notes to yourself specifically about air masses and how they're named. I would just pick a couple examples. The biggest thing that I want you to know is when you're looking at a map of the Earth like this, all of these big colored blobs that look like clouds are just simply air masses, and air masses are everywhere all the time. Obviously, air masses that form over water are going to be full of moisture. Those air masses are going to be more moist than the continental ones. And then, obviously, the ones that form near the equator, the E stands for equatorial and the T stands for tropical. You notice the pink and the red, those are warm air masses, and then the blue, shades of blue, are the cool air masses. And again, that just refers to where they formed on the Earth. So here's just a nice little slide that kind of breaks it down for you. So if you want to pause this slide and fill in the blanks in your chart on your scaffolded notes, they're pretty helpful. It gives you all the different codes for different air masses. It gives you what the source regions stand for. So go ahead and pause and fill in your notes. So air masses are constantly moving and they influence our weather all the time. So let's say it's the middle of summer and I have a CP, a continental polar air mass, move in. It could take the temperature down in the area and make things feel more dry since it formed over land. Now, where two different air masses meet is known as a front. So there are 4 different types of fronts. And you need to memorize the symbols for the different types of fronts. So I want you to add these 4 right here to your weather notes where you have high and low pressure. So a warm front, the symbol for that is red, a red line with half circles on one side. A cold front is a blue line with blue triangles on one side. Now, cold and warm fronts are always moving. Any place you have 2 air masses meeting, there's going to have a change in the weather. Warm fronts usually bring rain and low flat clouds. Cool fronts usually bring fair weather, sometimes storms, where 2 different air masses meet. A stationary front down here is where you have a warm front and a cool front pushing against each other. So neither one really has greater force. So they're kind of stuck pushing against each other, and that may create a weather system. So your symbol for the stationary front has blue triangles on one side, red half circles on the other side. An occluded front is where you have a warm and a cool front moving together. The cool front is moving a little bit faster, and they're purple, and they have the half circles and triangles on the same side. Now, not all weather maps you're going to see are in color, so it's good to know the color, but it's also really good to just memorize the symbols and notice just half circles, warm, just triangles, cold, symbols on one side, occluded, symbols on opposite sides, stationary. And you can see right here on this weather map, you might get asked questions like, where would you identify a cold front? So right here over the Atlantic Ocean. Or what type of front do you see across Canada? Up here, that's a stationary front. So put these 4 symbols in your notes that you'll upload to me to get your points. Go ahead and pause this for a minute. Now the other thing I want you to write from this lesson is the definition, just a brief definition of each of these fronts. So a cold front, the definition is the leading edge of a moving mass of cooler air. As a cold front moves into an area, the heavier cool air pushes under the light warmer air that it's replacing. So here's my cold front moving into the area in this picture. Cold fronts are often fast moving, and they can cause a sudden change in weather, including sometimes violent thunderstorms. You may have heavy precipitation with a cold front, and clear, fair weather often follows the cold front. Your definition of a warm front, the leading edge of a moving mass of warmer air. A warm front is defined as the change over a region where warm air masses are replacing a cold air mass. Warm fronts usually move from southwest to northeast, which is interesting, and the air behind a warm front is warmer and moister than the air ahead of it. Now, moving warm air masses collide with moving slow air masses. The warm air moves over the cold and denser air. They could create light showers, maybe some drizzle, precipitation. They're a lot slower moving than the cold fronts. Warm fronts may bring fog for several days and bring a longer, lighter storm. And they're possible to bring snow. They're less likely to have extreme weather. Now, occluded front. So I talked about this a little bit, but right here you can kind of see where I have a warm and a cold front moving together. But we talked about how the cold front is moving a little bit faster than the warm front. So areas of low pressure are usually associated with occluded fronts. The warm air mass is replacing the cool air mass, and the leading edge is a warm front. As the depression intensifies, the cold front catches up with the warm front, and the line where the two fronts meet is called the occluded front. So here's two fronts moving side by side, and then here's kind of what happens, and that forms an occluded front. I have a little diagram to show you. So here's These black lines you're seeing are called isobars. So they're just showing areas of pressure. So we have a low pressure zone right here that's moving along with the occluded front. Now our last type of front is the stationary front. So remember, this is where we have a warm and a cold mass, air mass meeting, and neither is stronger than the other, and they're pushing against each other. So that's your definition of a stationary front. Now, we have a nice little map here, kind of for your little pop quiz. I want you to pause this and see if you can point to one of each type of fronts on the map: a cold, a warm, an occluded, and a stationary. Alright students, go ahead and upload a copy of your notes, your little scaffolded notes that went with this lesson. You can do a picture or a copy of the Word document to get your points.